AWS Transit Gateway is a really awesome service. It's described by AWS as being a cloud router, and it connects VPCs and on-premises locations together using a central hub. So let's have a look at what this means. Now, again, what I want to do is show you a fully meshed architecture without AWS Transit Gateway to help you understand the problem we're trying to solve. Because when we have lots of VPCs and on-premises locations, it can get really complex. The peering connections that we set up if we use VPC peering can become extremely complex. So let's say we have VPC A, B, C, and D again, and we've established our VPC peering links. And as you know, there's going to be quite a few peering links here. We've got 6 peering links that we've got to set up just for 4 VPCs. And as you increase the number of VPCs, it gets very complex. So here we have 6 VPC peering connections. We then have a corporate office connected via a customer gateway. So how do we connect the corporate office using a site-to-site VPN to each of these VPCs? Well, we need a virtual gateway in each VPC. Then we need to establish a connection to the customer gateway from each VPC. And each of those is its own encrypted IPsec VPN. So there's 4 site-to-site VPN connections, and that's not even including redundancy. If you wanted to add redundancy, you'd need another customer gateway and double the amount of S2S VPN connections. So it starts getting super complex. Let's now look at the same architecture but with Transit Gateway. In this case, the same 4 VPCs and a corporate office. We stick Transit Gateway in the middle, and it becomes the network transit hub that interconnects the VPCs and on-premises networks. So now we have connections into each of these VPCs. The VPCs become attached to the Transit Gateway, and you specify one subnet from each availability zone, and that enables routing within that availability zone for any other subnets. We then have the customer data center. We've got the corporate office here with a customer gateway, and the customer gateway connects in. And that's it. This is now a service which is allowing us to connect through this cloud router, this central hub, to any of these VPCs. TGWs can be attached to VPNs, direct connect gateways, third-party appliances, and also transit gateways in other regions and also other accounts. So let's have a look at how it works with a DX gateway. So in this case, rather than using a site-to-site VPN, our corporate office has a customer router, and we're connecting into a DX location, and we're using a DX gateway. So now the DX gateway has a connection to Transit Gateway, and that's called an association. We then have the physical connection back to the corporate office from Direct Connect, and we create something called a transit VIF. So this is another type of virtual interface specifically used for Direct Connect gateways when they're associated to a transit gateway. So a transit VIF is only used when you're attaching a DX gateway to a transit gateway. Now, this architecture then supports full transitive routing between on-premises, the transit gateway, and all of those connected VPCs. As you can imagine, when your company gets bigger and starts using more VPCs in more regions, and you want to have that transitive peering between them, it can get so complex that Transit Gateway will really solve a lot of challenges. So that's it for this lesson. I'll see you in the next lesson.